Alright, so excuse the fan noise and everything. I've got noisy fans. But I will speak up so you can hear me. So this is a typical trailer installation of solar. Here I've got the factory wiring for the fans and lights. We've got an overhead vent fan. I've got a pump for the water system. I've got a charge control console. The C stands for control, but it has a charger in there for when you plug into shore power. So it has a 12-volt charger, and it has a disconnect switch. So when you're going to leave the trailer for a couple weeks and you don't want a phantom load or something to run the batteries down, you want to disconnect them. And this disconnects all the loads from the batteries, but it would still allow you to plug in the charger to shore to keep the batteries charged up. Then along comes your addition of solar. Now, I don't know how well equipped the trailers are that are solar ready. I don't know if that means they just have a connector. So this would be like a trailer that doesn't have any of that. It just has a box. It has some fuses and some 120 volt breakers in it, and it has a disconnect switch, and it has batteries. That's what these are. These are your, say, 2 flooded lead acid batteries that are in your house batteries for your trailer. So if you add solar, I've got 3 panels on here. Let's just say they're 100 watt panels, very common. They cost about $80 for a poly panel. They're solid panels. They're mounted to the roof. I mean, you could use flexible ones. I'm just, it's my own preference. And then each one of these is, because of the short distance, we've hooked them all in parallel with a 4-way splitter. We've only used 3 of the 4 ways. So we've got another connector for another panel or whatever. So then you've got 2, say 8 gauge or 10 gauge DC wires running down here to the solar charge controller. The solar charge controller is maybe a $100 MPPT charge controller. I've used the the P60AL. It's a blue case. It's transparent, kind of. You can see the components on the inside. Has a good digital LCD readout, and it is a positive ground controller, though. So because it's positive ground, the load shutoff feature doesn't work. Now, I discussed in another video building a circuit that would kill the loads. And in that other video, I just show you a relay. I don't show you where the relay is. It's on this YouTube channel. You can find it. It's on the forum. You can find it. That relay, the coil of the relay, so it's just an electromagnetic coil that gets energized, and that moves some switch contacts. That coil is powered by, and it's not drawn on here, it's powered by the load side of this. So if you wanted to add a disconnect for your if you wanted to add a disconnect that's similar to this, you would find where the disconnect is wired up, and in series with the disconnect you would put in your relay, or what they call a 12-volt contactor. 12-volt contactors are for more current, like 100 amps. Just be aware that some contactors will draw. I was looking at one relay system that could handle easily like 80 amps, but it would draw, how much would it draw? In operation, I calculated that it would draw like an amp or something like that, which is a lot. So you don't want something that high. So I'm using a relay that has 2 15 amp contact sets, and then I team them together so I get a total of 30 amps. But you could probably buy a 50 amp contactor that drew like, I don't know, like 200 milliamperes, no more than that. And you would put it in series with this disconnect switch. So it would have a small set of wires that would run from wherever the relay or contactor was over to the load side of here. So as long as this load was on, it wouldn't disconnect. But if you hit the load button on here, it would disconnect the loads, and it would be the same thing as you flipping the switch, because it's literally in series with the wiring of the switch. This switch may actually be inside of this cabinet though, so you may have to get into the cabinet, and that's why I'm saying if you don't feel like mess with it, just don't mess with it. It means you'll have your low voltage cutoff won't work. But if you have a modern sophisticated cabinet, it may have its own low voltage cutoff for loads, so you don't necessarily need to worry about that. But if it has a manual disconnect switch, there's a chance that it doesn't, and this may be in the form of an electronic button that you push. Hopefully it's a mechanical switch, but your mileage may vary. So in this very simple diagram, all I've illustrated is you've got 300 watts of solar power, all parallel together into the MPPT controller on the solar side, which is typically on the left side. In the middle is the battery. Always hook up the batteries first to the charge controller and make sure it's working before you plug in your solar. And that's it. That's all you need. You don't need the load leg connected to anything. If you want to get adventurous, if you want to get complicated, and again, depending on how your trailer is wired, it may be easy to find like a mechanical disconnect switch. You would already be familiar with it at this point. And you would just in series wire this 12 volt contactor. That would only be energized when this load is on. So if the load drops below a certain voltage, it'll disconnect the power to the coil, which will disconnect power to the system. You don't want to mess around with taking your loads out of here and running them into here and then running them off your solar charge. Don't do any of that stuff. The solar charge controller is set up so that if you were building a system from scratch and you had no load set up, no wiring, nothing, you could start with that. But don't. I'm just saying don't. And plus the reason is a lot of these solar charge controllers that are right now that are around $100, a good deal, they have a positive ground. So the disconnect feature, if you hooked your loads directly in here, wouldn't work. So this is the diagram. I don't know how else to explain it. It's really simple. You run your solar panels, which will typically have like, the wiring on them will typically be 10, maybe 12 gauge into a 10 gauge wire, because you're only going about 6 to 10 feet. And into the, and if you're only running 300 watts, 400 watts, into the input here, and then the solar port, and then the battery port goes to your house batteries. That's it. That's all you have to do. You don't have to do any other wiring. Very simple. It's just, I see all these really complicated setups, and then people get confused. Well, it's like, just leave your trailer wiring alone, add your solar controller, make sure it's close to your batteries, because it needs to know what temperature batteries are, and it needs to know what the voltage of the batteries are. So this wire here that looks like a lightning strike, it's just a zigzag, because that's how I drew it on the paper. It needs to be short, and it needs to be, I would say, with this kind of setup, typically make it 10 gauge. And the connectors on the P60AL, which I'm using currently, will definitely take a 10 gauge wire. So the distance should be no longer than you need it to like put the solar controller at eye height, so you can easily examine what the voltages are on it. So this should be at about 5 feet. The batteries should be floor level, say, so the wire run should be no more than 5 to 7 feet long. This, however, this could be a bit longer. The voltages in here are slightly higher. You're dealing with a working voltage of 19 volts. And if you had some situation where your solar panels were further away, like you were doing some kind of removable thing where you would, have this line running up to the roof or out the side, and then you had your panel stored somewhere, and when you got parked, you put this in the shade, and you took your panels and you set them up somewhere 20 or 30 feet away, then you would hook them all in series. And then, so the negative of one would be the wire that comes down here, then the positive would go to this one, then the negative goes to this one, and then the positive from this one comes out over here. So you have one negative from this side, one positive from this side, you combine them and into a bundle, and then you bring your cables up to the solar charge controller. That way, the 20 or 30 feet that you're running, you can use cheaper wire, like lighter gauge wire, I would still try to go with 12 gauge if you can, but you could probably get away with like 14 gauge with 300 or 400 watts. And that will significantly reduce the issue where when you run a long line, it doesn't have to be very long, with DC at lower voltages, you suffer a big penalty because of voltage drop. It just, think about DC like this. The electrons actually have to move from here all the way through here and then back down to complete the circuit. AC doesn't have that voltage drop problem the same way, because in AC it's pulsing. It's pushing an electron and pulling an electron and pushing an electron, and when it pushes an electron, it causes the next electron to get pushed and the next one to get pushed, and so on. So you only have to jump one electron, and it's way more efficient. Edison didn't have AC generators, he had DC, and you would have had to have an entire Edison generator station at the base of the Empire State Building to light one 100-watt bulb at the top, because DC just doesn't conduct that well, because you actually have to push the electrons all the way through, and it requires more energy. On the other hand, DC can be easier to wire. You don't have to worry about phases. Obviously in DC, the equivalent would be, you don't want to have like batteries where you flip the polarity and you hook up the positive on one battery to the negative on the other, and then you hook up the negative to the positive on that battery to the negative on the first one, and like short them out or something crazy like that. That would be the DC equivalent of phase collision. But yeah, this is a pretty simple trailer setup. 95% of the people are going to use this, and it's simple. So real quick rundown, each of these is a poly solid panel. They're almost square. Their dimensions, I don't remember, like 25 by, no, they're bigger than that. They're like 30, say they're like 40, no, let me think. They're like 30 by 40 or something like that, or 30 by 45. And they're $80 a piece. I used HQST. They looked flawless when I got them. When you order them from Amazon, make sure that you get the extra gift wrapping, because it puts an extra box around it and it protects it better during shipment. You can have them drop shipped to a UPS depot, and there's no pickup cost if it's a depot. And that way you know it's safely stored, and then you can come pick it up at their retail office at the UPS shipping depot. You have one of those close to you. So $80 a pop for the panels. The splitter, if you have one, I think it's like $15 to $18 for a pair of splitters, because you need one that goes from female to for male and one that goes from male to for female. And then the wiring should cost you maybe $25. And typically it takes the form of one female and one male. One female on one end of the wire, bare wire on the other. One male on one end of the wire, bare, so it's two wires. Or sometimes I've seen where you get an extension wire that's 25 feet long, and then you cut it in half. So you end up with a male on one end and a female on the other. And then those bare ends, be really careful when you put them in your solar charge controller, because they like to fray. If you're good at soldering, awesome, because you can solder them into a bundle, so they're like a solid wire then, and you don't have to worry about them spreading out and fraying, because you don't want any shorts. So you put that into your socket here, but you do it after you get your battery connected. Always connect your battery first, and then so you can bring it in and get it ready, but then before you plug it in, make sure your battery's in there, and the display panel, the display on the solar charge controller's on. For these, 10 gauge wiring is fine, because you're only running it about 4 to 5 feet. So the shorter the distance, you don't have to worry so much about the thickness of the wire. If you're going out longer distances, I mean, you can get into really, really thick wire, and then it's really expensive, it's heavy. So like 10 gauge be fine. To run from here to two, these are two, for purpose of illustration, these are two Group 27 100 amp hour lead acid flooded batteries. You can get them at O'Reilly's for about $90 a piece. The solar charge controller is about $100. So you're talking about 100 almost 300, so like 260 bucks. Wiring is another, with the splitters, is another 260, 280, 300, and then so 300 for the wiring, solar charge controller, and batteries. And then the solar panels would be about 80 a pop, so if you got 3 of them, which I consider to be a good starter. You need a lot more solar than you think you need, okay? If you think this is going to provide you with 300 watts all the time, you're living on some kind of fantasy nonsense. Consider that in an overcast day in this system, you'll probably get 30 watts. You'll probably get 10% of whatever the panel's rated at, even with an MPPT controller, out of the system. So you'll get 30 watts. You'll say, well, I have 300 watts on my roof, but you'll get 30 watts. So if you have 300, if you have 500, I think this P60AL handles up to 750 watts at 12 volts. And later on, you could do like a series parallel or something, so you have higher voltage coming in, and then potentially you could have more total wattage coming in if it's at a higher voltage. But I know that at 12 volts, if everything's 12 volts, everything's in parallel, then it'll handle up to 750 watts. So you could have 7 of these panels, but on an overcast day, you're only going to get 70 to maybe 100 watts out of 7 100-watt panels. And you would need quite a bit of surface area. So one of the things that I say is these things have vents, they have hoods, they have more vents, they have a skylight with a vent, and there is no real surface to put panels on. So if you have a curved trailer like this, you might look at curved solar panels. Or you might look at having an array that you can disconnect and you can put, you don't actually store it on the roof. You store it inside somewhere, and when you get to where you want to go, you take the array out, you prop it in the sun, and then you run your 30 feet of DC cable to your charge controller connector on the outside of the trailer. Which in another video I talk about using XT90 connectors. They're great. You could definitely get away with using XT90 connectors. They're an RC connector, very easy to disconnect and reconnect, unlike the XT60s, which Well recommends in his book, but use the XT90s. So say you have a bunch of vents and stuff on the top. You're going to need to build a super roof, like a Superman, right? You need a super roof. You need some kind of standoffs and some kind of box and system that you can lay all these solid panels in. It gives you extra shade for the trailer. I'm not suggesting you do it with a curved trailer like this, but say you had a fairly flat top, but it was curved a little bit the other way, so that you had a center peak, came down on the sides a little bit for rainwater, getting the rainwater off. You can, if you have if you're starting with an RV or trailer with basically a flat top, you can build up from that and have, with structural steel, go to a place that sells steel studs, a contract supply place, and you can get steel studs fairly cheap, and you can build like with 18 gauge steel studs and track. You can build a rack on the top, and then you can put your solar panels in that, and that way you have an undisturbed continuous area. You can still open your vents because there's clearance for your vents to open and close, and it keeps the sun directly off the roof, so that's nice. There's plenty of air underneath to circulate underneath the solar panels so they don't overheat. The other reason I don't like flexible panels is if they're on a hot roof, they can derate pretty quickly, which means they won't produce the rated power because they're running too hot, because the roof's too hot. Because they're flat and they sit on a flat roof, there's no air circulation underneath. So that's something to consider. So, but those are all extras. This is a very basic wiring. It's so simple. And what did I say? I said 80, 160, 240 plus, did I say 300? So for 540 bucks, you're in. Now, if you're really, really, really on a budget and you already have your batteries, even one battery, you get the solar charge controller. That's the big cost. You could even get like a maybe like $30 pulse wave modulated solar charge controller and use it for something later, which I'll discuss in another video. But you could start with that and one panel. Is it going to provide your needs? No. but is it going to give you like a very entry-level system, like 30 plus the wiring is say 40, so 70, plus one panel is 80, so you started at about $160 for your basic entry-level solar system. But for actually supplying like smartphones, accessories inside here like fans, lights, and pump, just the basic run-a-day things, you need really a minimum of 400 watts. I mean, I put 300 on here, but if you have space for 400, put 400 on there, and that easily puts you into the $600 category. So it's what it is. It's kind of steep to start, but then once you get more familiar with it, you can add on things and purchase stuff incrementally later as your budget allows.